NASA launched the James Webb Space Telescope, or JWST, in December 2021 to continue the work of its predecessor, the Hubble Space Telescope. Following in the footsteps of Hubble, the purpose of JWST was to bring information about cosmic understanding. It is used to discover galaxies that formed shortly after the Big Bang, and to determine whether planets orbiting other stars are habitable. Initially, the launch of JWST was planned for 2014 but launched in 2021. James Webb Space Telescope recently brought unexpected news about Jupiter's rings, moons, and auroras. What is it? You should be aware of it right now. For this, stick to the video till the end. We put a lot of work into our videos to keep you up to date. It will help us greatly if you subscribe to this channel, so we can reach the first 1,000 subscribers. Thank you very much. Let's get straight into the topic. Images of Jupiter. The Webb telescope of NASA has just captured new images of the Jupiter planet. Due to these pictures, the interior life of Jupiter will be better understood than ever before. Jupiter has tremendous storms, strong winds, auroras, extreme temperatures, and pressures. NASA and the European Space Agency spent $10 billion developing the James Webb Space Telescope to replace the Hubble Space Telescope. It was ultimately launched into orbit at the end of 2021 to commence infrared astronomical research. The Webb telescope aims to give a window into the distant past, enabling scientists to examine the cosmos 13.7 billion years ago, when the first stars and galaxies formed. The observatory is an astounding 1,600,000 kilometers from our home planet, 1 million miles. The Webb Space Telescope has provided us with the most precise image of Jupiter to date. Never-before-seen images of Jupiter's northern and southern lights and its whirling polar haze were acquired by a telescope in July. Imke Pater, a famous astronomer and professor emerita of astronomy at the University of California, Berkeley, said, "To be honest, we hadn't imagined such discovery to be so good." As part of global collaboration for Webb's early release science, de Pater and Paris Observatory professor Thierry Fauchet oversaw studies of Jupiter. NASA, the European Space Agency, ESA, and the Canadian Space Agency collaborate on the Webb mission. Seeing Jupiter's rings, tiny satellites, and even galaxies in a single image is remarkable. The 3 infrared filters on the observatory's near-infrared camera and IR-cam reveal the more refined details of the planet in images. Nonetheless, infrared light has been mapped into the visible spectrum, so that it may be investigated more thoroughly. Longer wavelengths are exhibited with a redder light, whereas shorter wavelengths are portrayed with a bluer light. Judy Schmidt, a citizen scientist, collaborated with scientists to evaluate and generate graphics using Webb data. Research findings. The Great Red Spot is the most well-known storm on Jupiter, although there are numerous more. Another wide-angle picture of the planet is also rather attractive. It depicts the planet's faint rings and 2 small moons against a galaxy-studded backdrop. According to the American and French study team in charge of the observations, the infrared photos were digitally colored to emphasize blue, white, green, yellow, and orange elements. Auroras can be seen stretching to enormous heights over Jupiter's north and south poles in the composite image of Jupiter, created from many Webb images. A redder filter is employed to depict the auroras, which accentuates the light reflected from lower clouds and higher hazes. Hazes circle about the north and south poles when seen through a filter that alters the colors to yellows and greens. The light reflected from a thick central cloud is seen via a blue-tuned third filter. The Great Red Spot and surrounding clouds seem white in these photographs because they reflect sunlight. Heidi Hamel, Webb interdisciplinary scientist for solar system observations and ARRAY vice president of science, said, "The brightness here implies a high altitude. Hence, both the Great Red Spot and the equatorial region include high-altitude hazes. The many brilliant white spots and streaks are likely the cloud tops of convective storms at very high altitudes. In contrast, clouds are rare north of the equator, forming a series of dark ribbons, faint rings. Webb gets an expansive view of Jupiter, which includes the planet's faint rings 1,000,000 times fainter than Jupiter itself, and its 2 tiny moons, Amalthea and Adrastea. The fuzzy dots in the lower background are likely galaxies photobombing the image of Jupiter. The image encapsulates the heart of the Jupiter System program, which explores the dynamics and chemistry of Jupiter and its rings and satellite system, according to Fauchet. Researchers who have begun utilizing the Webb telescope may now derive new scientific insights into the giant planet in our solar system by analyzing data gathered with it. How is the data processed? Telescopes like Webb do not transmit their data to Earth in MEP packets. Instead, it specifies how much light reached Webb's sensor. This information is received in its raw form by the Space Telescope Scientific Institute, STSI, which handles Webb's scientific and mission operations. When the data arrives at STSI, it is transformed into calibrated files for scientific analysis and subsequently sent to the Mikulski Archive for space telescopes. Throughout their research, scientists often use such data to develop graphic representations. Even though a team of professionals at STSI analyzes Webb's photos before they are made public, amateur astronomers known as citizen scientists often utilize the public data repository to get and process images. Judy Schmidt role. Judy Schmidt of Modesto, California, a professional image processor in the citizen science community, processed these recent images of Jupiter. She created the image of the tiny satellites in collaboration with co-investigator Ricardo Fuso, a planetary atmosphere researcher from the University of the Basque Country in Spain. Schmidt has never taken a course in astronomy. Nonetheless, since she joined an ESA contest a decade ago, she has been intrigued with image processing. Participating in the ad Hubble's Hidden Treasures, the contest urged the public to uncover new findings in Hubble data. The snapshot of a newborn star taken by Schmidt earned third out of more than 3,000 entrants. Since she joined the ESA competition, she has dabbled with telescope data, namely Hubble data, as a hobby. According to her, something about it really stuck with me, and I can't let go. I could do this task all day, every day. She started working with images of nebulae, globular clusters, and newborn stars because of her enthusiasm for astronomy photography. Her guiding philosophy is I aim to make things seem natural, even when they are nothing like what the eye can sense. Hamill, who collaborated with Schmidt to enhance Hubble photos of the comet Shoemaker-Levy 9's impact with Jupiter, is one of the professional scientists interested in these shots. Schmidt asserts that Jupiter's quick rotation makes it more difficult to observe than other distant celestial wonders. Due to the rotation of Jupiter's distinctive features at the time the photos were taken, it may be challenging to blend many images into a single viewpoint. Occasionally, she must use digital editing tools to arrange the images correctly. Schmidt is enthusiastic about improved views of star-forming areas, notwithstanding Webb's capacity to provide observations spanning the whole universe's history. Her research focuses on Herbig-Haro objects, tiny nebula regions where young stars form enormous jets. She said, I can't wait to witness these strange and wonderful newborn stars ripping holes in nebulas. James Webb Telescope, some latest findings. Detection of carbon dioxide. The James Webb Space Telescope continues to generate astounding findings. The observatory's detection of carbon dioxide in an exoplanet's atmosphere is a critical first step in this field of study. The existence of such a molecule has never been shown beyond a reasonable doubt. Multimedia specialists have already evaluated the photos obtained at the observatory. First, a brand new film compares how the Phantom Galaxy looked to the Hubble Space Telescope and the James Webb Space Telescope. A group of composers then provided a musical interpretation of the telescope's first high-quality picture of the Carina Nebula. The James Webb Space Telescope continues to generate astounding findings. The observatory's detection of carbon dioxide in an exoplanet's atmosphere is a critical first step in this field of study. Scientists have never before shown the presence of this molecule. Multimedia specialists have started sifting the observatory's pictures. They will begin with a brand new film that contrasts and compares how the Phantom Galaxy looked to the Hubble Space Telescope and the James Webb Space Telescope. Then scientists made a sonification of the telescope's first high-quality picture of the Carina Nebula. Incredible scientific advances. A new movie from NASA's Deep Space Telescope provides an overview of the cosmos. Fans of the Star Wars franchise may take a break from working on the James Webb Space Telescope to see a new film that takes them to the breathtaking Cartwheel Galaxy. This examination of star formation is fascinating given its proximity to a supermassive black hole. Engineers on board the Webb spacecraft often discuss their state-of-the-art equipment to accomplish space firsts. Northrop Grumman, the principal contractor for the project, managed an engineering team that made significant technological upgrades to make the telescope operable in deep space. Although the James Webb Space Telescope has only been operational briefly, it has already broken records and made amazing discoveries. Just a few days after the issue of the first scientific images from the James Webb Space Telescope, researchers discovered 13 galaxies with a redshift of 13. Approximately 300 million years have transpired since the Big Bang. Soon, intriguing new data suggested that scientists have exceeded this barrier with possible detections up to redshift 20. This would indicate that these galaxies emerged shortly after the Big Bang, around 200 million years ago. Webb discovered astounding structural complexity in the wheel-shaped galaxy Cartwheel. Webb used infrared light to discriminate between individual stars inside the star-forming regions of the galaxy and young star clusters around the core supermassive black hole. Due to the high quantities of dust, investigation of these locations requires infrared light. Okay guys, these are all for today. If you like this video and this topic, you should watch our last video. If you enjoyed this video, please like it and subscribe to our channel if you haven't already. If you think this video was helpful, please let us know in the comments below.